Our group presentation is on Adam Scott by the names listed below. As a brief introduction, Adam Scott was charged with an offence of rape and held in custody for 5 months. The sole evidence against him was DNA that was believed to be taken from the victim, but it was later found that due to a mistake with a plastic tray not being replaced during the automated DNA extraction process, Adam's DNA was mistakenly identified. This presentation goes on to explain the case in full. The two most important things when preserving evidence from a crime scene are continuity and chain of custody. Continuity of evidence is important because if the evidence becomes contaminated in any way, then it is no longer admissible in court. Therefore, the chain of custody must be documented in order to know who has had subsequent ownership of the evidence. This can be useful in many situations. If evidence goes missing and is found again, the individual who had it last can be confronted. Furthermore, anytime evidence is contaminated, perhaps with a small skin flake, the chain of custody should inform us who the contamination has come from so that they can be eliminated from inquiries surrounding the incident. Typically, the chain of custody begins with a member of the police or a forensic scientist who collected and documented the evidence at the scene, the courier who delivered the evidence to the lab representative who received the samples, and whoever subsequently analysed the evidence upon arrival at the lab. The laboratory's responsibility to maintain the chain of custody only ends when the sample is either destroyed internally or transferred to another location. In the case of Adam Scott, LGC Forensics was in charge of the destruction of evidence in Scott's spitting incident, which was unrelated to the rape case. The plastic trays used containing Scott's saliva DNA went on to be used in the rape case. After running the saliva sample through the National DNA Database, it was Scott's DNA that appeared. The incident occurred after a tray, used for a previous case, had Adam Scott's DNA still present on it, despite it needing to have been disposed of. There would have been no chain of custody, as it would have continued on with the sample, not the tray that the sample was being held in.
Upon first seeing this case, it is clear that the main cause of forensics inaccuracy is the residue that was left on the previous case that Scott was involved with. The inaccurate reuse of the disposable plastic tray DNA residue was left. Having this left shows an improper training in the laboratory setting, which could have affected hundreds of cases if not caught. With this severe human error, which caused this contamination by the LGC Forensics Company at Teddington Laboratories, shows that the disposal of these trays was insufficient. Even though Scott was 190 miles away from the site of the rape, which took place in Manchester, there was still sufficient evidence in the plastic tray that was reused. In this case of DNA analysis, a new robotic extraction was taking place, which training by lab staff didn't cover adequately, even though these robotics had been fully tested and were completely accurate, which yet again shows the human error within this laboratory. The misuse of the plastic trays in this batch weren't caught by staff until the 11th of October 2011. The laboratory technician who failed to follow the operating procedure was never identified, which yet again shows the procedures in this company are not up to scratch, considering they couldn't even identify their own employee. Scott went on to make a statement once being released, which said, "I am angry that I was falsely accused. I am angry about the amount of pain it has put me and my family through. I sincerely hope that justice comes for the victim and that the true rapist is caught. I am disgusted that it was taken this long for them to work out what went wrong. Considering the procedures with repeated analysis, it was clearly not flagged up, which could have resulted in false accusations and false imprisonment for many other people, since this was not caught." The root of contamination was human error in the incorrect use of plastic trays as part of the robotic DNA extraction process. That was the statement that LGC Forensics released in that report. Due to this human error, the lab claims that they had 1 in a billion DNA match to Scott, and though the added contamination, 26,000 samples were checked and then repeated, which they could have been repeated before due to this contamination. LGC has links to many police force networks around the UK, and considering that their main analysis is of DNA in cases, how did this happen? Yet again, going back to the inadequate training that staff had with the new robotics. This company had been alive for so many years, coming into its peak in 1991, to then have its reputation taken away from it due to the amount of time that it took for them to find this error. So why did it take this long? Even with 190 miles between Scott and the victim, and the DNA not being part of the semen that was recovered internally, but his DNA being recovered externally on the victim's body, which clearly showed that even in majority of times forensic science cannot be trusted, and is used around the world, that there are points where even forensic companies and police forces bypass evidence which is clearly not matching up due to either an error in analysis or or to cause an open and shut case. LGC are now at risk of going out of business due to new and exciting ways that other companies are coming forward to help the analysis and how to show other forms of evidence.
Scott's DNA was detected from inside a plastic tray that was reused when it underwent the DNA extraction process. This particular extraction in the case was carried out by an automated system machine, meaning there is no need for any manual steps between loading the sample and collecting the extracted DNA. Automated extraction systems are specially crafted tools that facilitate and improve the nucleic acid extraction process by promoting safety, quality, and consistently high yield. DNA isolation is needed to separate the DNA from the rest of the cell and other organelles so that it can later be amplified, then analysed for identification. However, only the extraction process needs to be discussed in this presentation, as this is where the initial mistake occurred. There are 4 principal stages that underlie any DNA extraction method, whether it's manual or automatic. The first would be cell lysis, which disrupts the cell and nuclear membranes, including denaturing and degrading proteins, which are abundant in cells and bound to the DNA in chromosomes. Separation of the DNA is the second step, where they separate the DNA from any other cell components, including cell debris, proteins, lipids, and RNA. Isolation is the third step, where you isolate the DNA into an aqueous phase. This step can also include the co-extraction of RNA at the same time. The fourth step is the store of DNA for future analysis. The storage of DNA is critical in forensic science so that there is no degradation, so therefore it must be stored at a temperature of -20 or lower. The sample is taken from the victim in this case with vaginal swabs, which pose a particular problem for DNA extraction because there is a mix of both female and male cells present that would interfere with the extraction process. Therefore, differential lysis is required to first remove the female cells so that the male DNA can be extracted for analysis and identification. Differential lysis, also known as differential extraction, is a technique allowing for the selective lysis and separation of DNA from 2 types of cells without combining their contents. For this process, you would need to first add SDSs, which is an ionic detergent that denatures proteins. You would also add proteinase K, which is a protease that degrades proteins and cuts the peptide bonds. You would also add EDTA, which is a chelting agent, and then after you've added all of them, you centrifuge. You would then remove the supernatant, which would be the female DNA. You then repeat the first step by adding DTT, which is a reducing agent for disulfide bonds. You would then centrifuge again and remove the supernatant, which is the male DNA that has been left behind.
So, what are quality standards in forensic science? They are the standards that apply to laboratories undertaking DNA profiling for loading of DNA profiles onto the National DNA Database and are set rules agreed by the NDNAD Strategy Board and reinforced in the commercial sector through police contract requirements with the commercial forensic service providers. Who manages these? The management of these standards is delivered through the National DNA Database Delivery Unit. The basis of the standard is accreditation against the BS/EN ISO 17025, which is the general requirement for the competence of testing and calibration laboratories. This is used globally as the standard applicable to forensic science laboratories and are interpreted for the forensic science context through guidance published by the International Laboratory Accreditation Cooperation. Accreditation against this standard is undertaken by the United Kingdom Accreditation Service. LGC is accredited for a broad range of methods across its forensic science laboratories. This includes documented in-house methods meeting the requirements for suppliers to the custodian of the National DNA Database. How are these quality standards assessed in forensic science laboratories? So, the accreditation against the standard involves on-site assessments by technically competent assessors across a range of areas at the heart of which assessment of organisations' quality management systems, the training and ongoing competence of the individual practitioners employed in an organisation, evidence of the validation and correct route use and tests and methods, and evidence that the work is impartial and free from external pressure. The accreditation is managed on a 4-year cycle with on-site visits undertaken at least annually by UCAS. The NDU issues technical standards for processing samples for inclusion on the National DNA Database. This ensures that all forensic service providers supplying profiles to the NDNAD are aware of and adhere to the technical standards for processing samples for inclusion on the NDNAD. So, what happened in this case? A new extraction method commenced operational at the Teddington Laboratories on the 1st of March 2011. In May 2011, LGC was subject to an annual surveillance visit by UCAS assessors in which the use of automated DNA extraction methods was checked and found to be satisfactory. Between then and the 12th of October 2011, approximately 26,000 samples were processed with no indication of any problems until the 11th of October, when it was discovered that a stack of plastic trays removed as waste from one of the robotic units was incorrectly reused. This was reported internally as a quality incident. As a result of this number of samples, they were reprocessed. Furthermore, this has resulted in procedures changing so that the empty plastic boxes removed from the supply drawer were marked as waste before being loaded into the waste drawer. How was the process of the DNA tested? This is where the robotic instruments manage each of the loaded samples through a DNA extraction process to deliver a tray of extracts that is moved to the next stage of the analytical process. Within the extraction process, each sample is robotically pipetted into a cell of a plastic tray made of 2x4 cells where it is mixed with reagents, heated, and later pipetted out for analysis. The plastic trays are collected from within the instrument from a stack of fresh, DNA-free trays preloaded into a plastic box that in turn is loaded into a drawer in the instrument by a technician. Once empty, each plastic box is transferred by a technician into the adjacent waste drawer to receive the used plastic trays deposited by the machine. However, in the case of Adam Scott, prior to the 12th of October 2011, there was nothing to distinguish an empty plastic box as being for waste only. Therefore, when testing the DNA for the victim to determine who had raped them, Adam's DNA had still been in this tray from a previous DNA test he had completed. Once full, each stack of waste tray should be removed by a technician and immediately disposed of as clinical waste. Due to the tray not being swapped and put into the clinical waste, the tray with Adam's DNA had been reused, giving a positive result for Adam's DNA rather than the individual who had raped the victim.
So, what can be done to improve the regulations and procedures? The root of the problem began with a human error because a stack of plastic trays has been removed from removed as waste from one of the robotic units, which was incorrectly reused and dealt with by the LGC lab technician, which therefore resulted in an incorrect conclusion as a result of a test which contained enough sufficient DNA to contaminate the rape sample. A forensic science regulator, Mr. Andrew Renison, wrote in his report that he was satisfied that it was Adam Scott's profile not from the samples taken from the rape victim, however introduced through the incorrect reuse of disposable plastic. But now the question is how can those issues and errors be corrected within a lab? Well, to correct those, an adequate and extensive personal training should be provided to the staff, in this case LGC technicians, and be taken through an extensive training of regulations and procedures that they would have to undertake within the line of work. And so it should always be important to always use or clean appropriately, clean the equipment appropriately, and disposed waste accordingly, which in this case led to contamination, which mistakenly and wrongly has resulted in Adam Scott being convicted over a crime that he has not committed. It's also important that using that the right set of pipettes are used, preferably with aerosol-resistant barrier tips in the pre-amplification area, to prevent any contamination before the appliance, but also after post-amplification, to remove any chances and minimize the risk of contamination. Also, the competency testing should be included within the LGC forensics to minimize contamination and always be checking for possible contamination within DNA analysis. Whereas the new automated systems, it's always recommended that the time that samples are held in open receptacles should be minimized, and the robot shall have a protective screen to minimize the outside exposure from technician or any other outside source. The robot program should be designed to prevent the contamination risk during sample transferring, mixing, and resampling. That is important. One of the most important parts, actually, because that's what can cause the transference of DNA, whether it be by human error or a mistake within the machinery, or failure to follow procedures accordingly. But last but not least, it's also important that DNA devices that are integrated in the company should be integrated with extraction, pre and post PCR processing, and genetic analysis shall be placed in a pre-PCR room to make sure that contamination is not possible or minimized. In the conclusion, after investigation and analysis into the Adam Scott's case, it was determined that the mistake that led to the wrong accusation was a human error by one of the LGC lab technicians, and human error can be very hard to control because it can happen because of many reasons. Many can be psychological, tiredness, or just lack of training provided by the LGC forensics in this case. But however, a spokesman for LGC forensics said at the time of the case, after the case, that the forensics regulator and the United Kingdom Accreditation Service have expressed their satisfaction with our investigation into the incident, their corrective actions, and LGC overall contamination avoidance and check-in processes. That therefore has not been... That statement from LGC Forensics have try to reassure the public that this type of incident will never occur again. But at the time of the case, the Adam Scott's case has caused an uproar in the forensics anti-contamination procedures to try and eliminate the chances of this error ever happening again, and make sure that no one will ever go and be convicted of a crime they have not committed in the first place, and which in this case resulted in Adam Scott being in jail for 6 months prior to release. And it should never take. The analysis should always be thorough to make sure that, double check to make sure that mistakes like this will never happen again in any other cases.